Hello everyone, I am Anala Gowda, an Electronic and Communication Engineering student studying in Sri Venkateshwara College of Engineering. Today I am going to give the presentation on orthonormal functions using Gram Schmidt orthogonalization procedure. So we will move on to the next slide. First of all, what do you mean by orthonormal basis function in digital communication? Orthonormal basis functions which is both orthogonal and normalized. All possible linear combination of orthonormal basis functions form a linear space known as a signal space, function space coordinate system. It is often convenient to represent a set of signal that are function in terms of a set of orthonormal basis function which is both orthogonal and normalized. All possible linear combinations of the orthonormal basis function form a linear space known as signal space, function space coordinate system. The coordinate axes in the signal space are the basis functions u1 of t, u2 of t or un of t. Any signal formed from the basis functions can be represented as a point in the signal space and the conventional vector theory applies. The graphical representation of the signal is called phasor or a signal constellation diagram, and the coefficients that represent signal Si of t can be written by vector. Next, what is Gram Schmidt orthogonalization procedure? The Gram Schmidt process, also known as an orthogonalization, is a method of transforming the vectors of a subspace basis from an arbitrary alignment to an orthonormal basis. A subspace, in this case, an inner product space, is characterized by a set of linearly independent vectors, each vector representing a subspace dimensions. The Gram Schmidt process takes those vectors and generates the same number of orthonormal vectors. This is accomplished by taking one of the vectors and determining the orthogonal projection of the next vector to the first. This is continued until all vectors are orthogonal, at which point all vectors in the subspace are normalized, making them all the same length and easier to work with. So, the Gram Schmidt orthogonalization procedure is explained by taking a problem as an example. Here, the problem is for the signal S1 of t, S2 of t, S3 of t, and S4 of t shown in the figure, find the set of orthonormal basis functions using Gram Schmidt orthogonalization procedures. So here, they have given four signals: S1 of t, S2 of t, S3 of t, and S4 of t. So S1 of t is from 0 to t by 3, and S2 of t is from 0 to 2t by 3, and from S3 of t is 0 to t by 3 and 3t by 3 to t, and S4 of t is 0 to t. So we have to find the number of basis function is required to represent the given force signal, and find the normal basis function of phi1 of t, phi2 of t, and phi3 of t, and phi4 of t. So before solving the problem, we should know the conditions for orthonormal function and orthogonal functions. The condition for orthonormal function is integral 0 to t phi1 of t into phi j of t, that is equals to 1 if I equals to j, and 0 if I not equals to j. Sorry, I told the 0 to t phi 1 of t, that is not phi 1 of t, that is phi I of t. So that are integral 0 to t phi 1 dash of t into phi I of t into dt, and 0 to t integral 0 to t phi I square t into dt is equals to 1. So this is the condition for orthonormal function, and the condition for orthogonal function is given as integral 0 to t phi 1 of t into phi 1 of t into dt is equals to k if I equals to 1 and 0 if I not equals to 1. So now we will move to the solution of the problem. So here the solution, given S1 of t, S2 of t, S3 of t, and S4 of t, we have to find n. We know that n is less than or equal to m, that is maximum value for n is 4 because and m is also 4. So step 1. So to find the first basis function phi1 of t, we know that phi1 of t is equals to s1 of t by root of e1, where the energy signal E1 is given as 0 to t by 3 S1 square t into dt, that is equals to 0 to t by 3 1 into dt. And when we apply the integration, will get as t, and by applying the limit, that is from 0 to t by 3, will get as t by 3j. Next, then S1 of t is given as root of E1 phi1 of t, that is equals to root of t by 3 phi1 of t. So substituting this S1 of t and E1 in phi1 of t, will get as S1 of t divided by root of t by 3. So plotting the graph based on these functions, we will get like this graph, and phi1 of t is equals to root 3 by t, that is 0 less than or equals to t less than or equals to t by 3, and 0 otherwise. So we will move on to the step 2. To find the other basis function, let us take generalized equation given as, the generalized equation is gi of t, that is equals to si of t minus summation j is equals to 1 to I minus 1 Sij phi j of t. For I is equals to 2, substituting I is equals to 2 in this equation, we will get as g2 of t, and here I is there, so s2 of t minus, when we substitute 2 in the place of I, will get as 1, so summation I is equals to 1, so we'll get as 1, so s2j phi 2 to t. So we'll go for G2 of t is equals to S2 of t minus S21 phi 1 into t. We have to find S21. So S21 is equals to 0 to 2 S2 of t phi 1 of t into dt, and from next 0 to 2 t by 3, because the interval is 2 t by 3 in the second graph. So S2 of t is 1, we know that as it is shown in the figure. So then phi 1 of t is root 3 by t into dt. So applying the integration, will get like this, and by applying the limits, 2 by root of 3 by t into t by 3. So substituting the value of t by 3 as t into t by 2, 2 into 3. Cancelling this, will get as 2 into root of t by 3. S21 is equals to 2 into t by 3. So therefore G2 of t is equals to S2 of t minus 2 into root of t by 3 into phi 1 of t. So we are plotting the graph for the G1 of t. So this is from 0 to t by 3 for S2 of t is 1, and this we are minusing with 0 to t by 3, that is 1, for 2 root of t by 3 into phi 1 of t. So we will get this as phi 2 of t, that is root 3 by t, that is from 0 to t by 3 and t by 3 to 2 t by 3. So by from the above graph, we can write the equation of phi 2 of t as root 3 by 2, that is for t by 3 less than or equals to t less than or equals to 2t by 3, and 0 otherwise. So note 1. So we know that energy of Q2 of t is equals to integral t by 3 to t by 3 phi 2 square t into dt, that is from integral t by 3 into 2 t by 3, that is root 3 by 2 whole square into dt. Applying the integration, will get 3 by t into t. Apply the limits, that is from t by 3 to 2t by 3. So 3 by t, applying the limit, will get 2t by 3 minus t by 3. So that is 3 by t by 3, cancelling t and 3 will get as 1. So if we get 1, that function is known as an orthonormal function. The second note is no overlap between phi 1 of t and phi 2 of t, that is orthogonal. So that is from 0 to t phi 1 of t into phi 2 of t into dt is equals to integral 0 to 2 0 to t 0 into dt, that is 0. So then if we get 1, that is orthonormal, and if we get 0, that is orthogonal. So step 3. third basis function. We have to find the third basis function. So we know that the equation gi of t is equals to si of t minus summation j is equals to 1 I minus 1 sij phi j of t, and here substituting I as 3, we will get g3 of t is equals to s3 of t minus summation j is equals to 1 to 2. Substituting I as 3 will get as 2. So s3 of j phi j of t. So S3 of t is equals to, sorry, G3 of t is equals to S3 of t minus, so applying the summation will get as S3 1 of phi 1 of t minus S3 2 of phi 2 of t. So therefore G3 of t is equals to S3 of t minus S3 1 phi 1 of t minus S3 2 phi 2 of t. Like then S3 1 of is equals to 0 to t S3 t phi 1 of t into dt. So that is the value for S31. Plotting the graph like S3t for S33 for S3t from 0 to t by 3 it is 1, and from t by 3 to t is 1. So we will get that last equation of S3 of t into phi 1 of t is equals to 0. S32 is equals to 0 to 2 S3 of t phi 2 of t into dt. So we are substituting like we are drawing the plot for S3 of 2, and we'll get as phi 2 of t into S3 of t as root 3 by t by 3 less than or equals to t and less than or equals to 2t by 3 and 0 elsewhere, or otherwise we can write. So we have to find the S3 of 2. Therefore S3 of 2 is equals to integral t by 3 to t by 3 root of 3 by 2 into dt, that is equals to root of 3 by 2 into dt, and we are when we are applying the limits from t by 3 to 2t by 3 we'll get as, at final we'll get as S32 is equals to root of t by 3. Therefore G3 of t is equals to S3 of t minus S3 phi 1 of t minus S3 2 phi 2 of t. Therefore S3 of t is equals to therefore G3 of t is equals to S3 of t minus root of t by 3 phi 2 of t. Next, so these are the graphs, so these are the plots for above equations. Like we'll get as G3 of t is equals to integral 0 to t G3 of t into dt. We have find G3 of t in the above equations. So substituting the intervals like 2t in integral from 2t by 3 into t, that is 1 of dt, and applying the limits from 2t by 3t we'll get as t by 3j. So at last, therefore, phi 3 of t is equals to G3 of t divided by energy of G3 of t, that is G3 of t divided by root of t by 3. Root of 3 by t G3 of t. So plotting the graph for phi 3 of t will get as this, and last we can write the conditions such as root 3 by t is equals root 3 by t is when 2t by 3 is less than or equals to t and less than or equals to 2, sorry, t, therefore 0 and otherwise. So note, so phi 1 of t, phi 2 of t and phi 3 of t are not overlapping. So these are the what is it, graph for the phi 3 of t, phi 2 of t and phi 3 of t. Then we will move on to the step 4. We have to find the last basis function. So gi of t is equals to si. We know that equation gi of t is equals to si of t minus summation j is equals to 1 to summation to I minus 1 sij phi j of t. When substituting I as 4, g4 of t is equals to s4 of t minus summation j is equals to 1 to 3 s4 of j phi j of t. So like expanding the summation we'll get this much, and removing the bracket and writing in one equation we will get this equation, and we have to find S4 of 1. So that S4 of 1 is given as 0 to t S4 of t into phi 1 of t into dt. So we have to multiply this S4 of 1 graph with phi 1 of t. So S4 of t is given as from 0 to t it is 1, and here from 0 to t by 3 is 3 root of 3 by t. So after multiplying these two equations we'll get as 0 to t by 3, that is root 3 by 2, that is S1 of t into phi 1 of t. Next, we have to find S41. So that is 0 to 2 S4 of t into phi 1 of t into dt. That is equals to 0 to t by 3 root 3 by t into dt. That is equals to 3 by t into t, applying the limits from 0 to t by 3. S4 of 1 is given as, at last we'll get as root of t by 3. For S4 of 2, that is from 0 to 2, 0 to t S4 of t into, here for S41 we are taking phi 1 of t, and for S42 we have to take phi 2 of t into dt. So after substituting this, we get at the last equation, that is root 3 by t into t by 3, that is equals to t by 3. And for S4 of 3 is equals to 0 to 2, sorry 0 to t S4 of t into phi 3 of t into dt. So after applying this plotting the graph for S4 of t and phi 3 of t, will get as this much, and after substituting we'll get t by 3, and for g and substituting the values, we'll get g3 of t is equals to S4 of t minus S41 phi 1 of t minus S42 phi 2 of t minus S43 phi 3 of t, will get this much. G3t is equals to 0, so G4t is equals to 0 and phi 4t is also 0. So note, number of orthonormal basis function is equal to 3, that are phi 1 of t, phi 2 of t and phi 3 of t, where n should be equals to 3 less than or equals to n equals to 4. So then S4 of t can be given as S1 of t, that is from 0 to t by 3 is equals to 1, and we are adding this S1 of t with S3 of t, like from 0 to t by 3 it is 1 and t by 3 to t is 1. We'll get S4 of t is equals to, that is S4 of t is equals to S1 of t plus S3 of t. So the signal S4 of t is linearly dependent signal. The number of orthogonal basis function, that is equals to number of independent meshes signals. So representation of given 4 signal in terms of basis functions, like it is given in all the basis function is given in one page, so that we can easily understand by seeing these functions. I hope this video is very helpful for you to learn this problem. Thank you for watching my video. Please subscribe, share and like the button.